It's my great pleasure to introduce our moderator for the panel, Michael Driscoll, co-founder and CEO of Metamarkets, to take away the panel on Beyond Hadoop. Over to you.
Thanks, Chris. Thanks, everyone, for coming directly from lunch to join us here. I guess I want to start by introducing our panelists. We're very fortunate to have three of the founders of some of the hottest big data startups in Silicon Valley with us today. MC Srivas from MapR could not make it. He's in New York. But his marketing team was able to put out a press release that he was here today. So he gets credit at least on Business Wire. He's here. So I guess I want to start. Amr is the CTO and co-founder at Cloudera. Has a doctorate in electrical engineering from Stanford, and was formerly high up in the Yahoo ranks before joining Cloudera. We've got Todd from Continuuity.
You're not going to give it a go?
I'm not going with your last names. You guys will. I'll only do a bad job. Todd is the co-founder and CEO at Continuuity, and Todd previously held senior positions with Teradata. He was an entrepreneur in residence at Battery until recently, and was even involved in the early days of Greenplum. And finally, we've got Ben Werther. I am going to use your last name because I won't get Ben from Platfora. And Ben is the founder and CEO at Platfora. He previously held senior positions at Greenplum, and actually Ben and I worked together at one point in his Greenplum days. So, I guess today the title of our panel is Beyond Hadoop, and I think that it's appropriate to bring this group together because I think we do represent sort of both Hadoop, sort of quintessentially represented by Cloudera, and both Todd and Ben representing companies that are looking to build upon the ecosystem and extend it in different ways. And I guess I'll sort of frame a few topics that I want to address today, and we're going to open it up for some questions from the audience as well. One thing, I guess 5 topics that we'll try to address. Hadoop solves the problem of scale, but what Hadoop has not solved is one of the problems of speed. We also want to talk a bit about streaming. There's a big interest in real-time data on the web these days, and we'd like to understand a bit more about how Hadoop can address some of those use cases. Broadly speaking, where does Hadoop fit into a big data stack as one of the enabling technologies there? What are some of the other things we see in a big data stack working, complementing some of Hadoop's weaknesses? Amr was mentioning the role of metadata in big data and how important that is, and some thoughts around how we can architect intelligently for including metadata. And finally, I think we'll maybe end with some discussion around different applications of Hadoop in the wild. Where have we seen it work? And I guess there's 2 ways we can talk about that. One is industry use cases, but also I think classes of data. What kinds of data do we see stored in Hadoop? Clusters, social graph data, log data, binary data in the form of photos, etc. So I guess I'll start first with the question of Hadoop's speed. And I think, Amr, I'll begin with you because I'm sure this is a question you often get. What are some of the answers that you at Cloudera give to clients who have a need for fast access to their data? What are some of the solutions that you guys provide to address that?
First, I think it's very important to distinguish what really speed means. So we answer the right question here. And that's always our first step, our first exercise with customers is understanding their use case and what they're trying to do. I can't tell you how many times I walk into customers after they finished a POC with us, and they tell us this query used to run in 24 hours, and now it runs in 15 minutes on Hadoop. So if you call that Hadoop is lower speed, then obviously you're mistaken. But obviously, the reason why it worked in 15 minutes is it was a problem that was a very well-suited problem for Hadoop. It was a heavy throughput parallel data processing problem that fits within the Hadoop model very well. Many of you, if you had attended any of my talks before or many of those in the community, you would see us use the analogy of the train versus the sports car. So relational databases are like sports cars. They're very good at getting from 0 to 60 in the smallest time, in a few seconds. A cargo train, can never get from 0 to 60 in the same time as a sports car because of how much momentum and inertia it gets it to get off the ground. Even a spaceship can't hit that. But once it gets going, the speed at which a train goes is way higher than a sports car. And not just the speed, the throughput, the amount of stuff it can carry is also way higher than a sports car. So that startup cost gets amortized over the trip. And that's exactly the analogy that Hadoop provides today. Hadoop is optimized for that problem of carrying and processing large amounts of data. If you're going to run an interactive OLAP query that's going to do multi-joins across a star schema, you're not going to get back the answer in a few milliseconds or a few seconds like a database, a relational database can. In Hadoop, that same query will take minutes. So a query that take milliseconds and seconds in relational databases will take seconds, if not minutes, in Hadoop. But queries that take hours in relational databases will take minutes, if not seconds, in Hadoop for the same cost, for the same amount of money that you spend on the system. So that said, Hadoop, with the introduction of HBase, has been making very significant improvements in terms of the latency dimension. HBase was built from the ground up to be extremely low latency. Within milliseconds, you can do lookups. But that's what you can do, lookups. You cannot do joins in milliseconds on top of HBase. So if you have a problem where you have the dimension table that you want to join with your fact table, HBase is a very good home for dimension tables, where you can do very, very quick lookups and you can update your data and change it. And then fact tables are very, very well suited for HDFS. So that's where how we see the problem fitting. And then if the customer tells us, no, what we really want to do is interactive OLAP, an interactive kind of manipulation on top of cubes, then we say then you should not be using Hadoop. What you should do is you should use many of the existing tools that have been doing this very well for a long time now, like MicroStrategy or Tableau. And many of these tools now do in-memory OLAP. And the speed actually is better than relational databases when you want to do interactive OLAP. So our strategy has been, how can we marry these existing technologies with HBase and with Hadoop to provide the best of both worlds? Mm-hmm. So at night, you generate your cube, and then you load your intelligent cube inside of a MicroStrategy iServer or a Tableau server, and then you can run it in low speeds over there. And finally, I would end with, sorry for giving a very long answer here. I would say that Hive itself has been improving by leaps and bounds, and expect to see Hive is the SQL language that we run on top of MapReduce and Hadoop. Expect to see significant improvements in Hive speeds over the course of this year. Because we hear that problem. We hear people saying, hey, we want to push more and more of our interactive OLAP into the Hive layer. So expect to see that as time moves forward.
And so, maybe as a natural segue to Ben, and I'll turn to Todd as well.
Yep.
Maybe to step back, I would be curious to address this question around Hadoop's speed, and I think we should frame it at, to your point, Amr, minutes, going from hours to minutes is a dramatic improvement, but into this realm of the human time, the time that you're willing to sit in front of your computer and wait. Maybe talk about how you've thought about this problem, Ben, and maybe provide some inspiration for your own choice to build something new.
Absolutely. Hi, everybody. So if you think about the role of a traditional, let's say a traditional data warehouse, so back in my days at Greenplum, that database that you're building really is serving two roles. And you can think about all that data that's coming in as being kind of crunched and aggregated and prepared and sort of funneled down from raw data into some usually aggregated distilled data that's able to be kind of queried fairly quickly. And those jobs run overnight or they run for hours, and these are pretty big kind of batch jobs. And nobody's waiting for them as long as they run within their window. And then you have the kind of the interaction. So I'm a user sitting in front of a web browser, and I hit drill down to see more data, and I want that thing to come back to me in sub-second, milliseconds. And if I'm waiting 20 minutes for that, that's kind of a non-starter. And those are two very different things that a traditional database does, and we had to scale systems to kind of handle both of those. So Hadoop, in its natural sense, is quite good at the first case. It can do batch things if you set it up well. It can do them at very high throughput. It's completely not suitable for the second. everybody today, many vendors are talking about building Hive interfaces for BI products. So that's, the people imagine, oh, suddenly I'm going to be able to use Hive as my database behind a BI product. It's like, okay, if you're prepared to wait 20 minutes when you click the button for the next page to load, that's the experience. People say, no, it can't really be like that, and then they dig in a bit more, and it kind of is. And so this is kind of a marketing checkbox for those guys. It kind of inspired us to focus on how will that new stack above Hadoop really look? If you forecast out 5 years, we see a lot of people struggling with this explosion of data and recognizing that, like, putting it into a traditional Teradata or Oracle or even a Greenplum, at some level, it's not even about the scale of data and the expense of the machine. It's about all those decisions you have to make to get it into a relational database form. Sorry, I'm okay. And so if in all those decisions you get into relational database form mean that you spend months or even years potentially getting it ready. And so with Hadoop, you just land the data there. It's really easy to get going. But the inspiration for us is, how do you then take the data that's landed and directly leverage that data and do real-time, the real-time OLAP BI exploratory things that Amr was talking about with sub-second interactivity without having to do all the manual moving things around or pumping things back into a traditional database. And so our product's not on the market yet, but we'll be talking a lot more later this year about ways of using Hadoop in this way that are really much more about the business user rather than a lot of sort of IT people building the plumbing.
And maybe Todd DeWayne, and I'd be curious, as someone who's spent a lot of time both at Teradata and Greenplum.
And Yahoo.
And Yahoo. That's right. I should have given you a shout out for Yahoo, right? How do you see, maybe specifically, how do you see some of these MPP databases fitting in to address the speed issue of Hadoop? And maybe again, what led you to believe that it was important to go off and build something different?
Yeah, that's a great question. I mean, when I think of Hadoop, I do think of it as, the kind of like the new next generation data warehousing platform, right, for big data, whatever big data means to you. Your question about, how do the MPP databases sit in there and solve, the speed question? As it turns out, most of the MPP databases are really not that good either, right, at doing speed, and that's because of the way they're designed, right? They're designed for full scan OLAP type queries. Some of the MPP databases are much better now at kind of like tactical queries. So Teradata, for example, is extremely good at doing tactical queries, but will never compare to the speed of an Oracle, which is straight up OLTP database. But I think what we're seeing in the market is that there is Hadoop, and people are plowing big data into Hadoop, and the ways that they are going about trying to support better interactivity for the end user would be maybe something an approach like Ben's, or the other stuff we've been talking about, we're pushing stuff up into memory, or getting much more kind of like ad hoc. But one really interesting thing that Amr talked about in his 15-minute diatribe was the fact that, like, build the cubes on Hadoop and then stick them somewhere else. But the problem with that approach is that then the data in your cube is always out of date. Right, so it's the classic kind of like batch load cube building that goes on in traditional BI, where people will build a cube at night or build a cube every 6 hours or whatever it is. So you're always out of date with your data, right? And I think where people are trying to drive to, and specifically as you talked about the real-time web, is that the model we want to get to is on the real-time web, there are a bunch of signals happening, whether that's a user clicking here or liking this or checking in here or searching for this. You need to be able to take those signals and flow them straight into your analytics platform and be able to act on those signals straight away. So I actually think that one of the big waves that's happening in the Hadoop ecosystem and big data in general is a bunch of people trying to feel out how to solve that. And you see a number of things out there. There's like S4 from Yahoo, which was kind of a streaming platform that we built at Yahoo. Has some good characteristics, has some bad stuff. There's Storm, which is another one. It's different to S4, but it has its own characteristics. There's 8 streaming. There's Hadoop Online. So there's a number of people trying to solve this problem. I think it kind of like points towards...
Hadoop as well. There's another one to
Hadoop.
On the collection side.
Yeah, Hadoop's similar, closer. I'd say they're kind of like, I think of them more like kind of like, in some ways, Vertica. Right, and it's just what they're trying to do. I think is kind of like say, look, Hive really doesn't work, and it doesn't. If you're from the traditional database world, Hive's a pile of something or other. but the SQL that it supports. But what you can do is pump SQL in, and get that passed, and then query generated, and then push it down to your big data platform. So, they've got an interesting approach, I think, but they're really not streaming. So, if you compare it to the traditional world, you have the data warehouse platform, and you have the kind of like CEP vendors, whether it's Esper or Streambase or something like that. In the big data space, there's Hadoop, and with a bit of Xbase sliced on here. And this area is now an area, a fertile area where people are looking at to try to solve, because it's a very real need.
Yeah. So one question I have, and I'll pitch it to Amr, is in this notion of streaming data. So we certainly think about batch queries, ad hoc historical queries, where you have to go back and pull out a lot of archival information. And I think people have said that disk is the new tape, and memory is the new disk. But in the case of streaming, we've seen a lot of individuals using Hadoop for kind of continuous batch processing. I think even at Yahoo, that was often the case. The sort of provocative question is, do we even need Hadoop when we're doing continuous processing of data? As things mature, do we see where is the role for Hadoop in this for these type of workflows?
Yeah. So two things. I mean, first we need to explain what streaming is. So we're speaking the same language here. So streaming, typically, in my definition, is the ability to query the data within a very short time window after data has been generated. Which actually is two parts. So one part is on the ingestion side, meaning the ability to ingest data very quickly, but also on the query side, being able to query the data very quickly. So streaming systems, typically, they only process a window of time, not the full window. It's a window of time, or a recent window of time of the data being collected. So that is not to the exclusion of needing to also be able to do batch processing over the last 40 years worth of data. So they are complementary. They're not exclusive to each other. Todd mentioned a number of the technologies now that we're watching very closely to see which one is going to take over in the streaming world. Storm seems to be at the head right now, but there's also S4 and a number of others. So that would go back to the ability of ingestion and being able to ingest data very quickly and query it soon after it has been created, if not as it is being collected. The solution that most of our customers deploy right now is what is called mini batch. So most of our customers do mini batch right now, and that seems to be actually working fine for the majority of them. Mini batch meaning that every 5 minutes we still collect our data using Flume or any pure data collection framework, and then every 5 minutes we would go in MapReduce and run a query over the last 5 minutes, and which usually finishes very, very quickly when it's such a small data set. So that solution is deployed by most of our customers right now. But yeah, there is some that are asking and saying, no, that's not good enough. I want to be able to go down to the ability to do it in real time, meaning a few milliseconds after data has been collected. Will that succeed? I'm still actually, I think it's an open question. It's not answered yet. If you look at the complex event processing space, CEP for short, it never took off. It never took off compared to databases. And the reason why it never took off compared to databases is mini batch worked fine in databases. So we'll have to wait and see whether the user expectations of how quickly they can query will move from the mini batch realm to the real-time realm.
And do you think is it inefficient? We live in this IO-bound world. Does it seem inefficient when we have these massive streams of data coming in to push them onto disk, only a few minutes later to be pulling them back off in a Hadoop process? Or do you think the efficiency is not really an issue for most people?
I mean, it's inefficient if you don't want to keep your data. I mean, in general, you are collecting your data because you want to keep it. So you're going to be storing the data regardless of whether you're going to be querying it or not. But you're right. If the use case is I'm purely just counting the numbers in the data and I'm not going to be storing it, then yes, it is inefficient. But typically, you actually want to keep your data as well.
Yeah. I think the question went more to, though, like, do you land it first and then raise it back up again and query it, or do you just like stream it in through memory and then land it, right? And I think that for me anyway, and look, I've been building these parallel data platforms for like a decade now, right? I think that's more likely, right? We're ending up with this kind of like tiered storage. To your point, like disk is the new tape or whatever it is, right? So we have this kind of like tiered storage hierarchies of where people are putting data depending on the type of workload query pattern that they want to execute. And we're seeing that not only in the big data world, but if you look in the traditional BI world as well, all the traditional BI players now have probably kind of like, the leading ones anyway, hybrid row column support, right? Why? Because the storage format is different. Now they're starting to see them pushing it into memory. So you're seeing a lot of players like Cognitio and those types of guys saying, hey, we have a whole in-memory piece as well that goes along with our disk place, our disk storage, right?
So SAP has HANA.
HANA, yeah, exactly. HANA, column store in memory, all of the rest of the, hand wavy, good stuff, right? But it does work, right? So we're seeing, I think, a shift now, right? Where traditionally it was just like, okay, just get the data onto the disk, and then, because memory was so expensive, we'll just do a full file scan, right? That's what the MPP databases used to do, and then you found ways to collapse that down and not do a full file scan. Now, because of the cost of infrastructure coming way down, I think we're starting to see a lot more novel approaches to the architecture of data systems, and therefore the query workloads that we can put on them. And it's much, much richer landscape if you're a consumer of BI or analytics now than it was 10 years ago. It's much, much richer.
Yeah. I think there's an interesting way to think about this, which is, one of the presumptions of doing streaming is that you know your queries ahead of time. And that's a presumption that I think holds in some very sophisticated organizations. You may hold in some financial services organizations, web companies. Most of the world, particularly when it comes to big data, it's like the standard model is, okay, this year my project is to get it into Hadoop. Next year I'm going to start a project to figure out what can I do with my data. and it's really a situation where the presumption that you're going to know so far ahead what you're going to do with it is so far from the reality of a lot of this sort of Main Street type usage that I think it's a very interesting, powerful application of being able to extend and take the questions you've already asked and continue to refresh them and rebuild them in real time is great, but it never replaces being able to go back and ask that next question. And in fact, one of the interesting analogies we've seen and a really powerful role of Hadoop is if you think about the role of ETL. In a traditional architecture, for those of you who don't know, ETL stands for extract, transform, and load. It's the idea of that pipeline that manages the flow of data into your database. And if you think about a traditional ETL pipeline, it's much like a streaming architecture where data's coming in, and you have to make decisions about what to do with that data as it's flowing, or else it goes away. The data gets dropped. And so you decide how you want to map it and organize it into your database, and if you change your mind afterwards and that data's gone, unless you landed that detailed data in some raw form, it's too late. I think Hadoop actually opens up the door to a whole new kind of ETL architecture, and this is something we think a lot about, where the raw data goes and lands in Hadoop in just whatever raw form it's in, and the ETL pipeline actually starts from Hadoop up. And that means I can actually think about it in a more iterative way. I can ask a set of questions, and then if I change my mind and I want to go a different direction or I want to dig deeper, the ETL process can become an iterative thing that's going to go back and revisit the data. And that's a whole different way of thinking about it than what people have been doing up to now.
Mm-hmm. Yeah, actually, I have to agree. I mean, that is the power of Hadoop, is this ability to give you a re-entrant ETL system that you can go back later and scalably redo ask the questions that you didn't predict ahead of time.
Yeah.
And I think the thing I would add to that, I think, is like, why is Hadoop being adopted in that pattern, right? Well, I mean, clearly the technology can do that, but more of it is being driven by cost, right? Where your traditional, BI platform, your, data warehouse was at a cost price where you were like, well, I've got this data, but I don't want to put it in there, so I'm going to drop it on the floor. And now people are saying, I don't need to drop that data on the floor. I can put the entire detailed data onto HDFS. And HDFS will scale out horizontally for probably like 99% of all companies in the world, right? They just plow data into HDFS and just keeps going. There's a few people there like a Yahoo or a Facebook or, some of the bigger banks that maybe that doesn't work out for. Right? And so people have found this platform that they can store all of their detailed data, their grain data, and then reprocess it, which wasn't the case before in the traditional world.
Right, and I guess that's, it's rare that anyone has ever developed a schema that didn't break at some point.
Right.
So the idea that you can create those schemas later and not before seems to have a lot of advantage. So maybe to get to this question, then you were talking a bit about ETL, which is sort of the lowest level of the stack to some extent. I've heard it called the coal mining of the information age. Is the dirty work of ETL. And maybe I'll start with you, Ben, since you kind of brought it up. Where do you see this? What do you see this stack looking like? And maybe even going a level down from the ETL. Talk a bit about cloud and virtualization as maybe the substrate upon which Hadoop is being run. What do you sort of see as the sort of pieces in this big data stack that's emerging, of which Hadoop is a big part?
Absolutely. So I'm going to take it from the kind of analytical, sort of analytical versus transactional perspective. There's a world of things you do that are about knowing what happens, processing things that happen as they happen and storing them away into bank transactions and the rest. But if you want to understand and analyze, I think it starts at some level with Hadoop as sort of the mixing bowl and the sort of landing ground for everything. We've been talking to some large Fortune 500s who have massive investments in data warehouses, and each one of those was at one point maybe envisioned to be the enterprise data warehouse that was going to kind of rule them all, and they realized that then the next database is bigger. And so now finally with Hadoop they can think about a platform where they can actually just kind of mix all that data together. It's far less powerful today. It's far more clumsy in a lot of ways than each of those individual systems, but it's able to handle all of the data, which none of those other ones can. So I think Hadoop has the fundamental kind of neutral ground where the raw data lands. And that means there's a bunch of plumbing in terms of how that gets in there. There's a Flume and other more interesting ways of interoperating with traditional databases to move data to and from. I think there's, the question of is that on-premise or off-premise? I think that it generally depends on where the data is being generated, but I think it's going to be largely on-premise for companies that aren't heavily cloud invested yet, and it is going to move to the cloud slowly because these volumes are so large, systems are they don't come and go. That data is there, and it's just going to keep growing. And so those investments you can kind of plan for. But I think the big thing about the stack is, from our perspective, the real difference is it starts with what I was talking about a moment ago about ETL starting from Hadoop and going all the way up. I think the big change we see is how do you think about this sort of stack where the activities above, the business intelligence and analytics and all these types of things don't just have that lens of the data that was kind of pre-sanitized because somebody a year earlier aggregated the data down to that schema. They have visibility into all the data, and you can't touch petabytes of data sub-second. So it's all about how do they kind of communicate with this sort of on-demand ETL pipeline to help make that kind of a reality where they can sort of change their views into the data continuously. And so we think a lot about that, and I think that stack is going to really open the door to sort of big data in a much more practical sense where real people can actually use these massive volumes rather than today where it really is rocket science where you need very, very skilled people just to manage the pipelines of the ETL and the plumbing and not be losing data and having things fail continuously. Lots of interesting work to come in the years ahead.
And so I'm going to let Todd respond, and then we're going to turn to the audience for questions. Todd, quickly, I know you and I have chatted a bit about the future of the cloud. Where do you see Hadoop kind of fitting in with evolution of cloud architectures, and where do you see some of the things beyond Hadoop adjacent to it?
Yes, a really interesting question. I mean, I'm not sure it's clear, right? I mean, people obviously think
cloudy.
of it's cloudy, yeah. Hadoop is a IO-intensive platform, right? We looked at running Hadoop on virtualized infrastructure at Yahoo and decided against it. So in some ways, I think of Hadoop as the data fabric, right? A data path, where it is the cloud. It's your analytics data cloud, right? Whether you're going to end up running that on VMware or OpenStack or whatever it is, I don't think so in a production environment. I mean, I think I've seen people try it, but they don't really like it, and they don't necessarily like running it up at Amazon either. So, where I think of as, whether Hadoop or HDFS or MapR is that fabric you lay down on top of the hardware or not, the most interesting stuff is going on above it, right? Right now, the Hadoop experience, despite, people like Cloudera's best efforts, right, which is doing a great job, right, is still more like the homebrew computing club of, 30 years ago, right, where you take a Hadoop and you take a Hive and you take an HBase and you maybe got a Mahout and you got something else, an Uzi, and you're trying to put all this stuff together, and it's hard work, right, and that's just the nature of where we are in the maturity of this industry. 30 years ago, it was the same in BI, right? And then the BI industry and the analytics industry had 30 years to get to where we're at now. What I think is going to happen, certainly in the Hadoop ecosystem, is that we're going to get more and more of these pieces of functionality merged, and made easier to consume, right? And so the next wave of folks who are looking to get into big data, because they hear that the CIOs like, I need a Hadoop someone told me I need a Hadoop, right? It's like, those guys, or gals, are like, what? It's about it's like the Linux experience. I don't want that. I want the kind of Visual Basic, Visual Studio or Apple experience, right, with my big data platform. And so that's, I think one of the big impetuses for us as an industry and us as, companies in that industry is to try to deliver a much, easier to consume, easier to, deliver value on top of that platform experience.
So who will be the Apple of big data, I guess, is the question.
So, given our name is Cloudera, can I talk about the cloud thing?
Yes, absolutely. Okay, we'll constrain to 2 minutes, and I'm going to ask the host, though, can we go to 2:25 because we started at 1:55, so that way we'll get a few minutes of audience questions.
Yes, that's what he means.
Great.
Yes.
Yeah.
So people should start thinking about the question they want to ask right now.
Yeah.
As soon as I'm done,
line up.
Yeah, maybe line up. I don't know where the mics are or what's the plan there. So there is two types of cloud. There is internal clouds and external clouds. External clouds for big data, it's going to happen, but it's going to take some time. Cloudera, actually, our initial business model for the company, we were going to build a cloud service, and we felt a very strong resistance from many of the companies of moving into the big companies that we want to sign up. Startups were willing to sign up, but it's hard to make money from startups. The big companies were very resistant to moving out to the cloud because of the logistics of moving all of the data out. Not because of security, it's logistics. They have the Teradata system here, the NetApp here, the EMC here, they want the Hadoop here. So that was but I think it will happen, just there is lots of OpEx savings that you can get by doing that. Now, with regarding to internal clouds, meaning virtualized infrastructure like VMware, Richard McDougall, who's one of the CTO office at VMware, gave a very good talk last week at Strata that I highly recommend people to go watch online. And the overhead of virtualization is actually very low. It's only like 2 or 3%. The problem is not that. The problem is most virtual infrastructure is built by using shared storage, by using a big EMC filer. And that's against the ethos of Hadoop. Hadoop is, no, the storage is going to be local on my VMs. So VMware and other virtualization technologies like them are looking at how can we bring the storage for Hadoop-like infrastructure to be local on the same servers. And when they do that, then it will help a lot with the deployment, actually, in many of the big companies that already standardize on virtual infrastructure.
You should never run Hadoop with EBS-backed storage on AWS. That's the take-home lesson. Yeah. So we'll open it up to some questions for our panel, right here in front.
What are the legal requirements for holding data and for how long?
Which country are you in?
No, I'm talking about US. I mean, for enterprise-sized companies, aren't there?
Yeah, it depends on the industry, it depends on the country. So in the US, for example, in the financial industry, you actually have to hold it for 7 years, right? In other industries like the web industry, you cannot hold it for more than a year without anonymizing the data you're holding.
Right.
Or 3 months now?
Yeah,
that's going down.
3 months.
Yeah, so it really depends on the industry. And it goes back to anonymization. It's like you can retain it for longer, but you need to properly anonymize all the personally identifiable.
Yeah, there's a whole set of rules, A29 rules, basically for anonymization of data. And it's one of the things we had to, basically tackle at Yahoo because, we were in every country, with people from every country, different rules for data, where you can land it, what you can do with it, how you have to anonymize it, how long you're allowed to keep it, how long you're not. It was a nightmare, honestly. We had an entire team dedicated to basically the kind of like data policies, and then we had to implement that in software. So it depends is the answer.
Other questions? Raise your hand if we have got a roving mic here in the audience. Right there.
Could you elaborate on the cost of Hadoop hardware now and in the near future? One of the big attraction of Hadoop is inexpensive hardware. So what are we talking about? And
yeah, I can give you, including even the money you pay Cloudera to help you manage that hardware. But I mean, it's a point that Todd made earlier, is the cost. One of the key benefits of this new wave is the economics of storage on a per byte basis. And that's very important because what's happening, if you're going to keep data at the lowest granularity, the value density is very low, meaning when you divide the value by the bytes, the value per byte is not as high as the value per byte in the already filtered aggregated data. Obviously, that has much higher value per byte, which justifies putting it in very expensive systems. But when you're storing the original highest fidelity raw data, you obviously now have very low value on a per byte basis, and hence you need a system with a very low cost on a per byte basis. So right now, and I can walk you through the math offline if you want to hit me after this, right now our customers are seeing the cost per terabyte including the hardware and everything, the management software, the support services, to come in around $400 per terabyte. That compares to 10 times to 100 times as much with other systems. Not just other systems, meaning relational systems, but even storage systems. It is 10 times cheaper. And the reason why is twofold. The reason is the fact that this software MapReduce and SGFS, when Google published and designed their systems, from the ground up, was built with the assumption that we're going to use the cheapest hardware out there. We're going to use hard disks failing all the time, memory failing all the time, servers failing all the time. We're not going to use military-grade equipment that only fails once every 100 years, because guess what? We're going to be replacing it in 2 years anyway. So that's number one, why the cost came down significantly, all of this intelligence being built in the software. And number two, the open source model is amortizing the cost of development across many, many companies, that the cost of the system becomes extremely low.
Now, just as a, just to play devil's advocate a little bit here, right, and get to the other side of the story, right? Everything Amr has told you is absolutely correct. Cost per byte is way down, because of all of the reasons. But the one thing you do have to be a little bit aware of is the TCO, right? Because by the time you've hired your staff of 5 to 10 people or Cloudera's consultants to kind of like carry and feed and keep the infrastructure up and then build your applications, and you've got a team of like another 10 developers, you've got 20 people on staff, and then your TCO has gone up to actually get value out. So there's a really interesting trade-off going on now in the industry, I think, where it is, how do we bring that TCO down? Like, it's in all of our benefits to do so, right? I mean, especially compared to the traditional platforms. And the traditional platforms are also able to take advantage of the depression in prices in commodity hardware. So that's coming down as well. So there is a really interesting, next kind of like 5 to 10 years shaping up in this industry.
Yeah, and I think the last thing on that is I think talking to some of the Fortune 500s we've talked to about this, there's almost a bet they're making where Hadoop's cheap enough to use to store the data. It's not cheap enough to use the data from, in a way. So it becomes a place where they'll put it there today because it's the only place they can afford to put it. And they may have a few people doing some very sophisticated things with it, but they're kind of planning for the day when things evolve to the point where now they can actually take advantage of that in a big way. And they know that it's not there yet. So there's a little bit of a kind of a waiting game going on as well. Not everywhere, but in some places.
Yeah, sorry, just very quickly. So totally, I mean, that reducing the cost, the total cost of ownership is very important, and there is 3 fundamental pillars that enable that. One is making sure there's a big workforce out there that knows how to work with this technology. So Cloudera, we have been doing training for many years right now. Last year, 10,000 people have been trained worldwide on this technology, and we're planning to double that this year. Number 2, making sure that there's companies like Continuuity and Platfora that brings down the barriers of new skills adopting this platform to the level where it's not very, very expensive to bring that on. And number 3, to make sure that the system works with existing infrastructure, existing ETL tools that you already have and already know very well, existing storage systems and relational systems that you already have and know very well. How to integrate better with that ecosystem is very important.
So I think we've got time for yours and one more question, but I will ask, if you can address it to one of the panelists, then you'll get one panelist responding, so we'll have time for one last question. So go ahead, sir.
Sure. For the Cloudera, I just wonder what kinds of the big feature you want to look at the Hadoop and the open source is upcoming good feature. And the second follow-up for that is what you contribute back to the Hadoop open community. I think that this is I want to look at the healthy community, the growth.
Yes. So start by answering the second part and then go back to the first part.
That sounded like 2 questions.
Yeah, it is 2 separate questions, that's true. So the second part, one of the advantages of Hadoop really right now, the powers of Hadoop, is that community is very, very healthy and very diversified across many, many companies. I would say at Cloudera specifically, right now the engineering team is about 70 people in the engineering team. The company overall is more than 200. The 70 engineering team, 40 of them, the only thing they do is just contribute to the open source community in collaboration with many, many players out there. The big features coming up that I'm personally very excited about, and I know many of our customers are very excited about, in CDH version 4, which is currently in beta, you can go get it right now and try it out, is the HA features. So there's a lot of HA features being added for the name node being significantly more resilient.
It's high availability, right?
Yes. Oh, sorry. Thank you. By HA, we mean high availability, reducing the length of downtime when there is an issue. Same thing for the job tracker with MapReduce Next Gen. It's now significantly better than before when it goes down. So that's the biggest thing. Longer term, real-time, more real-time kind of stuff. I'm excited about that to see how that will evolve. And applications like Continuuity and Platfora that make it easier for this platform to be adopted within organizations.
So I'm actually going to, in respect to my good friend DJ, who is patiently waiting to get on stage, I'm going to end with that public service announcement. I think actually what I'll do is one quick question. I'm actually going to call on Brett Shepard, analyst in the front row. Brett, I know you must have some thoughts or questions for the panel here.
I asked Amr this, and yes, I would have questions for all three of the excellent panelists as well as for Mike, but to ask for Amr, one of the interesting talks at Strata was from Expedia that they were the first company that I've talked with that discussed using a Hadoop cluster in production that spanned more than one data center. Are you finding many customers beginning to do that beyond ones like Expedia or Facebook that have been experimenting with it?
I wouldn't say it's many of the customers. I would say it's in the single-digit % range right now in terms of number of customers doing that. But most of the big customers do run in more than one site for disaster recovery reasons, right? So they have a primary site, which is the production workload, a secondary site, which is the ad hoc workload, for replica. And when the primary goes down, then the secondary becomes the primary, and you stop the ad hoc workloads. So that's very, very common in our customer base. But as having one continuous cluster where you're storing across both, not many of our customers do that right now. Though with HBase we have synchronized. You can have replication across sites, and same thing with HDFS. You can do sync between sites as well, distributed syncs between sites.
Okay, well, I'm actually going to ask Todd and Ben one word. If you're going to be one word for the future of what's beyond Hadoop, one concept, what would it be? And I'll put you guys on the spot.
Well, I'm going to not answer your question, but the one word I'm going to throw out there is exciting.
Exciting.
That's
okay,
what
great.
I think is the next decade.
I look at them. They are there.
2 words: beautiful and simple.
Beautiful and simple. Okay, great. Yeah. So you guys got the last word. Thank you to this great panel. I really appreciate all of you coming today. Let's give them a round of applause.